quick, graph y equals the sine of the quantity 2x minus pi over 3 by hand, 3 different ways. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones shown here. Press pause as needed anytime during the video. The first way is with the sine dance. As you did with other parent functions, we need to factor out the 2 in the argument. And so when we do that, it's 2 times the quantity x minus pi over 6. These are called equivalent expressions. The advantage to the right-hand side is that the minus 6 means a phase shift to the right, pi over 6, and the times 2 means the period is divided by 2. Pause is needed. Recall the graph of the sine function, one period or one wave, and remember the 5 key points of interest. These key points and all points are affected by the parameters in the equation, namely the 2 and the minus pi over 6. As noted previously, b is equal to 2, and that affects the period inversely, which means the period is now 2 pi times the reciprocal of b, which is a half, or the period is just pi. Pause is needed. The minus pi over 6 shifts each point to the right pi over 6 units. So we have a period of pi, a phase shift right of pi over 6. We need to change the units along the x-axis to accommodate this. So we're suggesting marking off every pi over 6 and use the domain negative 4/3 pi to positive 4/3 pi inclusive. And that's how we did that. Pause is needed. The initial point is normally at the origin. It's going to be shifted right pi over 6, so it'll go to pi over 6, 0. Y-coordinates are not affected by these parameters. The end of the period is normally at 2 pi to the right of that initial point, but our period is just pi, so we're going to go pi away from pi over 6. So when we add pi to that, think of pi as 6/6 pi, plus 1/6 is 7/6 pi. So 7/6 pi, comma 0. Halfway between these 2 points is another point of inflection, which would occur right here at 2 pi over 3, comma 0. Halfway between these 2 points of inflection is a maximum, so the same thing will happen halfway between these two. There'll be a maximum point, and that will be at 5 pi over 12, comma 1. Remember that each pi over 6 is 2 pi over 12. And finally, halfway between these 2 points of inflection will be a minimum value, and that's going to occur at 11 pi over 12, comma negative 1. Pause is needed. Connect the points as a sine wave, frown or concave down, smile or concave up. This is one period of the sine wave. We can duplicate this in the negative direction by going back pi, the period, from each of the points, especially the key points. Going back pi from each of those 5 key points. Can connect the points as a sine wave, frown, and then a smile. And compare it to the parent function in blue. So notice we do have a phase shift to the right from blue to green of pi over 6. And the period of the blue function right here is 2 pi. And in that same width, we're going to get 2 periods of the function that we're graphing. So 2 periods in the same width as the parent function, and you can see where that 2 is coming from. Pause is needed. Second way is with a table. So these are our axes values, so go ahead and complete the table, and these are the values you should get. Create a second table in green, and remember times 2 inside the parentheses multiplies each x value by its reciprocal 1/2. And this minus pi over 6 is going to shift each point to the right, so we're going to add pi over 6 to each x value. Pause is needed. By the order of operations, we multiply first, then add second. So multiply each x value by a half, and then add pi over 6. So 0 times a half is 0, plus pi over 6 is pi over 6. Keep the y coordinates the same. So pi over 6 comma 0. 1 times a half plus, pi over 2 times a half plus pi over 6. We'll have to get a common denominator, so this is like 3/12 plus 2/12, which is 5/12 pi. Y coordinates are unchanged. Pi times a half plus pi over 6, that'd be pi over 2 plus pi over 6. Here I got a common denominator of 12, so I should have gotten 6, but got 8 pi over 12, which is 2 pi over 3. Y values are unchanged, so 2 pi over 3 comma 0. Half of 3 pi over 2 is 3 pi over 4 plus pi over 6, common denominator of 12. 9/12 plus 2/12 is 11 pi over 12. Y value is unchanged, so 11 pi over 12 comma negative 1. And then finally, 2 pi times a half is pi plus pi over 6. So 6/6 plus 1/6 is 7/6 pi, comma 0. Pause is needed. Connect the points as a sine wave, concave down, concave up. Plot another one to the left. So again, we come back a period, which is pi from each of the points, especially the points of interest. And connect the points as another sine wave. Third way is using algebra and patterns of the wave. So recall that we can rewrite this as 2x minus pi over 3. And so this time we're going to use the non-factored form, the equivalent form. Again, recall the graph of y equals the sine of x, one period, and the points of interest. The initial point has an x value of 0. To find out what the x value is on the initial point for our graph, we need to set this argument equal to 0 and solve for x, and that will tell us the initial x value. So setting that equal to 0, we might want to multiply each side by 3 to clear out the fractions, add pi to both sides, and then divide both sides by 6. So our initial point is going to start at pi over 6, comma 0, because this starts at 0, 0. So we plot the initial point. The final point has an x value of 2 pi normally. To find out what ours is going to be, we set again that entire argument equal to 2 pi and solve for x. So again, we're going to multiply both sides by, oh, let's let you try that. Let's go ahead and try that. So we'll multiply both sides by 3, add pi to each side, and divide both sides by 6. So it ends when x is 7 pi over 6 and the y coordinate is 0. Pause is needed. We have 2 points plotted. We need to fit the other 3 points of interest in our graph in between these two. So the point halfway between these two is another point of inflection. So I got to go halfway between these two. And we can see that that's going to happen at 2 pi over 3, comma 0, point of inflection. Pause is needed. So we have 3 points plotted. We need to fit the other 2 points of interest on our graph. So halfway between these first two red points is going to be a maximum. So halfway between these two is going to be a maximum at 1, y equals 1. So to find that halfway point, we can see that the coordinates are going to be 5 pi over 12, comma 1. We might have wanted to mark off every pi over 12. That might have helped as well. So we have 4 points plotted. The fifth one we have to fit in is this our last point of interest. And it's halfway between these 2 points of inflection, and it's a minimum down here. So we can plot it. And then we can also just come up with the coordinates. So 11 pi over 12, comma, negative 1. Pause is needed. So graphing 2 periods, this is the graph that we get. Just curious, do you have a favorite way to graph this one? Now you try one. Graph y equals the sign of the quantity 1/3 x plus pi over 6. Use either method or all 3 methods for the practice. Hint, you will need to change the units. Pause is needed. So you'll notice here the period of our graph is 6 pi. Phase shift to the left, pi over 2. And we have 2 periods here, so you can see it starts here at negative pi over 2, comma 0.